In 1992, in a small town called Nordenau in the Sauerland region of Germany, something happened that no one could explain. A former slate mine had been abandoned for years. The tunnels were empty, the work was done, but water kept seeping through the rock walls. Local people started drinking it, and then they started talking. An old woman said her blind eye could see again. A retired miner threw away his crutch. A woman walked in with a blood pressure of 160/100 and walked out with 130. Word spread, first locally, then across the country, then across Europe. Within a few years, hundreds of people were showing up, every day, lining up at the entrance of an abandoned mine to drink water from a rock wall. They called it the Nordenau phenomenon. But nobody knew why it worked. They tested the minerals, nothing unusual. They tested the pH, unremarkable. The temperature, ordinary. Then, a scientist in Japan named Professor Sanetaka Shirahata from Kyushu University got curious. In 1997, he published his analysis. The water from Nordenau contained 200 to 300 parts per billion of dissolved molecular hydrogen. That's 200 to 300 times higher than ordinary tap water. A molecule so small that no one had thought to look for it. And then, the pattern revealed itself. Shirahata tested other waters, famous waters, waters that people had been traveling to for decades. Lourdes in France, 5 million pilgrims a year, over 3,500 reported cases. Hydrogen. Tlacote in Mexico, nearly 10 million visitors a year. Hydrogen. Hita Tenryosui in Japan, drawn from deep underground. Hydrogen. 4 locations, 4 continents, centuries of stories, and the common thread was a molecule that nobody had been measuring. It wasn't faith, it wasn't the minerals, it wasn't the altitude or the temperature. It was chemistry. The simplest molecule in existence, dissolved in water, doing something no one expected. We didn't discover hydrogen, we just made it accessible. Axiom H2.